A confirmation about the audio, please, guys. If you're able to hear me out perfectly well, kindly confirm the same. Thank you. We shall be starting in a couple of moments. Anshu, bombogenesis is basically the aspect of development of a bomb cyclone when the cyclone suddenly intensifies within 24-hour time period. If it suddenly intensifies beyond what is expected out of it, if the pressure or the low pressure drops by more than 24 millibars, then the low pressure becomes much more intense, the cloud formation becomes much more intense. That is a bomb cyclone. So the germination of a bomb cyclone is what is bombogenesis. Nitin, regarding the cyclonic circulation in Arabian Sea and Bay of Bengal, wait for some time. After we are done with oceanography, when we are done with the aspect of stratification of waters, that how even oceanic conditions lead to more cyclonic formations in the portion of Bay of Bengal. After that, we'll have a kind of a conclusive evidence and a kind of a conclusive mind map for the cyclonic circulation. But just to get an idea, please understand, under even in the case of Enzo cycles, when we talk about, let's say, the normal conditions or the La Nina conditions, it favors cyclonic circulation in Bay of Bengal. El Nino conditions, they will favor circulation in Arabian Sea. Similarly, when we talk about negative IOD as well as neutral IOD, it will favor the circulation of cyclones and the germination of cyclones in Bay of Bengal. Only in the case of positive IOD will we have a cyclonic circulation in the case of the region of Bay of Bengal. Any MJO is basically a traveling system of low pressure, high pressure condition. Think about it that ENSO conditions, when we talked about IOD, you had pressure difference at two ends, and that creates a kind of a circulation. And that difference in pressure is created due to temperature difference. But imagine a low pressure, high pressure system which travels across the planet just like a conveyor belt or just like a rotating belt. So that is MJO. Temperate cyclone cannot feed its own like tropical cyclone heat engine. No, that is not going to be there. In the case of temperate cyclone, it is largely dependent upon the aspect of the frontal development, Pranay. So in majority of the cases of temperate cyclone, while sometimes you will find that excessive low pressure means it will attract more winds will rise up, further intensifying the low pressure, but heat would not be generated. Heat is very important in order to intensify the low pressure beyond a particular point. So that is why temperate cyclone generally will have milder winds as compared to the tropical cyclone. Okay. Anshu, is sinking air in eye of cyclone due to low pressure at its base? Not exactly so. It is largely because, see, low pressure, if it is there at the base, why will you have a sinking air column? Low pressure will always have a rising air column, and that rising air column is there on the sides in a circular motion. So, in between, there is a kind of a suction of air created, which leads to the sinking air column and a kind of a adiabatic compression as well. Why all cyclone don't have an eye? In the case of a temperate cyclone, the rise of all the tropical cyclones will have an eye, and it will be a significant amount of eye. But when we talk about the temperate cyclones, they don't the air doesn't rise up from a central position. The air can rise up across a frontal region, and meanwhile some air can rise up vertically in between as well. So that is why some temperate cyclones will have an eye, but not all of them. Okay. Right. Vivek, see, in the case of geography, the aspect of providing mind map, that is actually a bit limited because each of the concepts are interlinked with the other one. So that is why it is not going to be, for example, mind map is easily to be provided, let's say in the case of environment, let's say in the case of history, where you have a timeline where you can concise and conclude everything. But in this case, you don't have a fixed timeline, you have a fixed concept around which the other concepts will develop. At max, what you can do is, in the case of geography, you can basically summarize all or list out the various concepts that you have studied, but that would be a kind of a listing of content per se. But if you want me to list those contents, I will be happy to do so if the time prevails. Okay. So, hello, a very warm good morning to all of you, and welcome to Baiju's Exam Prep IAS. Welcome to another session of geography. Today, the session is going to be from 10 to 8. I'm sure you would be aware of that. So, first lunch break we will have at 1. So, 1 to 2 is going to be the lunch break. And in between also we'll be having breaks. And then we will have 5 to 5:30 as another break. So, in the meanwhile, we shall be starting with the portion of India's climate, that is the Indian monsoon. Then we will be taking a look at the global climatic distribution, which is going to be very theoretical portion. Let me tell you and let me make you aware from now itself that after this module, when we are going to approach the portion of global climatic distribution of world climatic classification, that is going to be very, very theoretical. So that is where if you start losing your interest in that particular chapter, please don't get perturbed by it. Hold your horses, because after that we shall be entering into the portion of oceanography. Oceanography, we will try to finish it today itself, because once we start developing a perspective into any particular topic, it is always advisable, even for you guys, when you start your preparation, when you start your revision, it is always advisable that once you get your teeth into a particular concept, leave it out only after the entire concept is finished. Otherwise, it will require a reiteration. So today we will try to finish the portion of oceanography and step into the portion of Indian geography as well. Okay. Meanwhile, any doubts that you have, any kind of issues that are prevalent, any portion of the areas that we have covered till now, any of them, if it causes any trouble, please feel free to let us know and we shall try to solve it up. So today we start with the portion of India's climate and India's monsoon. Now, India's monsoon is, and there is no exaggeration in this, it is one of the most complex climatic phenomena which is active anywhere across the planet. It is very, very complex in the sense that you have multiple factors which are at play simultaneously. In fact, just to give you a hint about how complicated this entire process is, that in order to, you would find in newspaper headlines and newspaper articles that this time we are expecting a normal monsoon, this time we are expecting a higher than average monsoonal rainfall, and so on. Where do we get that data from? We get that data from computer simulators, the advanced supercomputers, where you feed in the temperature, let's say at Pacific, the temperature in Atlantic, the temperature in Indian Ocean, the temperature over Indian landmass, all those data pointers you fill in, and it will give you a result that this is the expected rainfall. So, just to give you a hint or an idea about the level of interference that various places across the planet have on Indian monsoon, it happened once where, while entering the data for the various different factors which can contribute to Indian monsoon, few of the people whoever were responsible at that point of time, they managed to enter some discrepancy in the case of North Atlantic Ocean's temperature. Imagine, we are studying about Indian monsoon, North Atlantic Ocean's temperature, and that mistake was in decimal points rather than 0.3, somewhere around 0.2 or 0.4 was mentioned. Now, the computer result showed us at the end of it that it is going to be above average rainfall, whereas that year we received a deficit rainfall. So even a minor discrepancy can totally give you an unexpected result, which tells you the amount of factors which are at play for India's monsoon. Now, this monsoonal phenomena, what is monsoon? When you hear about the term monsoon, here and there in various parts of the planet, you will hear about the term that this experiences monsoonal type of climate. This land experiences monsoonal type of climate. Monsoon basically represents the seasonal reversal of wind movement. So that is what is the exact aspect of it. So monsoon, when you hear about it, it represents seasonal reversal of wind movement. Okay, that is exhibited by or indicated by monsoon. Now, many places across the planet, generally across the tropical areas, they will experience some amount of reversal or change in wind direction. But a complete reversal in wind direction as compared to one season and then compared to other season, a complete reversal, so to say, is experienced in countries like India only. India is one of those unique areas where we do experience a complete reversal of the wind direction. That is why India is referred to as a land of a true monsoon season. And it is one of the very few areas where we experience this. Now, the aspect of Indian monsoon, this has been known to us for a very long time. Even if you take a look at our traditional calendars. So we have basically classified these monsoonal seasons as the rainy season. So we are aware, we have been aware that monsoons, they bring us rainfall. Monsoons have always been very, very important to us because in India, around 70 to 80% of the annual rainfall is received only during 3 to 4 of the monsoonal months. Imagine, around 80%, 70 to 80% of the rainfall is concentrated in those 3 to 4 months. Rest of the year, we get very little amount of rainfall. So everything, be it the storage structures that we have built, which stores a lot of water for drinking supply, drinking water purposes, for agricultural irrigation, for electricity generation, all those to the aspect of crop growth of crops for agricultural purposes. Everything is dependent on the monsoonal rain. If the monsoonal rains, they fail us any year by chance, then immediately we suffer from the disasters associated. For example, crop failures bring about a higher poverty level in the rural areas. The rural distress rises up beyond proportion, and that is very hard to recover from. Drinking water supply is furthermore important. And areas such as the Vidarbha region of Maharashtra, the eastern part of Maharashtra, the region of Telangana, all these areas, they significantly get impacted if the monsoons, they start to fail. So that is why monsoons have always been very important to us. And if you move from north to south, from east to west, you will come across various different traditions and cultures where we all end up worshipping the monsoonal rainfall directly or indirectly. You have various different customs and customs and customary traditions, rather to say. All of them, they end up worshipping and praying for the monsoon rain. For the first time, the world came to know about this monsoonal phenomena and the monsoon phenomena through the Arab travelers. Now, around the 10th, 11th century and so on, the Arab travelers would frequent India significantly through the sea route. Now, there they were aware of the fact that if you go to India during the month of June, it is very conducive to go to India because the winds are moving towards India. In the sense that if you have, let's say, this as the portion of the Indian landmass, the peninsular part, they were aware that the winds are in this direction during the month of June, July, and August. So they would plan their journey towards India during this time. And they were also aware that during the months of December, November, December, January, and so on, the direction of the winds is completely reversed. And they would plan their journey away from India during these times. So they were aware of this. And that is where these Arab travelers, they named this phenomena as Mausim. That is where the name is derived from. They named this phenomena as Mausim, which meant basically nothing but seasons. Now, throughout the 1600s and so on, there have been various different explanations provided in order to explain the phenomena of Indian monsoon. You had various people from Halley, Hadley, everyone trying to provide a theory regarding why there is so much amount of concentrated rainfall in these 2 to 3 months. Now, few of those phenomena, for a few of those explanation and theories were in the category of the land gets heated up, that creates low pressure, attracts winds from the nearby water bodies, that causes rainfall, that is monsoon. Later on, our understanding of the monsoon increased quite significantly, especially in the second half of 1900s. That is when India launched various different explorative missions along with, at those point of time, it was Soviet Union. So we launched various different exploratory missions across the water bodies in Indian Ocean, measuring the sea surface temperature, measuring the wind direction, in what is famously referred to as the monsoon exercise, or what was referred to as MONEX. So after that, our understanding increased quite significantly. But till today, we do have various different variables which appear to impact the Indian monsoon. Until today, in fact, as late as last year, you had another research paper which was filed for peer-to-peer review, and that research paper is still not officially accepted, so we will not be talking about that. So the research paper was filed with the aspect that the temperature of Northern Atlantic and Southern Atlantic, they have a role to play in terms of the amount of rainfall received in India. So there is still a lot of research being done. Various collaborations with various countries are on the way, and that is where we hope to understand the monsoons in a better manner in the coming days. Why do I say in a better manner? Because still you would be reading and coming across the newspaper headlines that, okay, monsoon, and that will start appearing, let's say 1 week from now, that monsoon is going to be slightly delayed, or monsoon is going to arrive 1 week in advance, and such kinds of newspaper headlines will frequent. But why don't we have the exact prediction? It also happens, for example, last year, the prediction in the month of May was that 2022 we are going to receive surplus rainfall. But the month of June was extraordinarily dry. And in order to compensate for it, the month of July was very, very rainy, causing a lot of destruction and devastation. So we still don't have the exact accounting for what will happen and what is going to happen in the coming days. It is largely left as a post-mortem exercise. That, okay, June was very dry because you had a negative IOD. June was very dry because you had a suppressed phase of MJO. July is very rainy because this time you have a convective phase of MJO. So you have various factors which are at interplay. Now, we don't have to ignore the fact that monsoon is just another season in India. India has got almost all the seasons present. From north to south, from east to west, again, you will encounter various different types of seasons. And that is again very unique to this landscape. You will find a very distinct winter season, especially in the northern part of the country. The southern part of the country does not experience that distinct a winter season. northern part of the country will have very harsh winter along with very harsh summer season as well. Now, that has largely ascribed to our social aspect, our social behavior, our customary traditions, our cuisine, the food that we consume, the clothes that we wear. All of that has been traditionally determined and shaped by India's climatic condition. If you think about it, you would rarely come across a situation where in different parts of the country, we had to struggle to find food. Food was always available. And the same cannot be said about the Europeans. Europeans, when they embarked upon the entire phase of colonization, they were actually thinking of getting preservatives for their food because the food could not be produced in those areas throughout the year. But that is not the case in India. We have always been food sufficient. And that has shaped our entire social behavior, our entire social milieu. That is why you will not find historically Indians being the aggressors in various different landscapes. We have never been aggressors. We have never ventured into other territory to capture that territory. Why? Because whatever has been present in our territory has been more than sufficient in order to fill our bellies. And that is ascribable to India's climate. So this particular portion becomes very important for the entire aspect of your understanding of climatology. Everything that we have learned up till now, it culminates into this particular chapter of India's climate. Now, this is obviously going to be relevant both for your prelims as well as for your mains. So in your prelims, you can expect questions from the portions of basics of monsoon, the features, factors influencing monsoon, influencing India's climate in itself, and then factors influencing monsoon, then after that also the aspect of western disturbance, these are relevant for your prelims. And when we talk about the mains examination, in the mains examination, you get questions from, again, factors influencing climate and monsoon, and after that, western disturbance. So here, in this portion of India's monsoon, we will follow a unique approach in the sense that, first of all, we shall be trying to understand the basics, that what are the factors which influence India's climate, then what are the factors which influence Indian monsoon. We shall try to understand all those factors first, because all of them we have already studied. We will have a quick recap of that, and then after that, we will be transitioning into the entire concept being woven into a single thread of a story, so that it becomes much more organically consumable by you also. One thing that I would like to reiterate here: in no other reference book, in no other textbook that you will come across, will you find this approach for looking at Indian monsoon. In many of the books, and you are free to explore as many books, as many reference materials as you can, everywhere you'll find that Indian monsoon is mentioned in a kind of a hodgepodge manner, where they will mention it to you that this is Indian monsoon, and they will keep adding on that this factor also influences Indian monsoon, and this also influences Indian monsoon, creating a lot of muddle up in your brain. So what I would recommend to you is follow this approach initially, at least, so that you understand the entire concept. Once you are able to understand the entire concept after the session today, it is very imperative, very important for you to be able to weave out the entire story on your own. So take a blank piece of paper after the session and start writing it on your own, that what you have understood about how the Indian monsoon is at play. So that is where this session is going to be very different from the portions that you have been across in the textbooks or that you will be referring to in the textbooks. Okay. Now we start first of all with the factors influencing the climate of India. Before that, a couple of questions are there. Uh, Ajit, trade winds blow steady in the same direction and in a constant course. Is this statement true or false? So this statement will be true. If it is a generalistic statement about a trade wind, that statement should be true, because a trade wind here refers to a kind of a permanent wind system. So it will be true. It should be true. And Utkarsh, so much harsh weather conditions in North is just because of its topography and its internal structure? Absolutely, yes. Not even the internal structure, entirely its location and the topography. Okay. So now we start with the factors influencing the climate of India, first of all. So India's climate is very unique in the sense that we get to experience different types of seasons and also to different and varying degrees. So when we take a look at the various factors, one of the major factor is the latitudinal extent. Latitude in the sense that the entire country lies in the northern hemisphere. Location, if you take a look at it, location is in the northern hemisphere. And that means you don't have a consistent equatorial climate. If it would have lied across equator, it would have had experienced an equatorial climate, but its location is entirely in the northern hemisphere. After that, Tropic of Cancer passes through the central part of the country. Okay, Tropic of Cancer passes through the central part of the country. Now, how is that relevant? That is relevant because regions which lie to the north of Tropic of Cancer, you'll find that they will experience very harsh summer conditions as well. They will experience very harsh winter conditions as well. So you have the presence of both subtropical as well as tropical climate, which is experienced in the country. So subtropical and tropical climates are experienced. So this is largely a resultant of the location that India has. It is located in the northern hemisphere. Now, here we also have to understand that there are other factors at play. For example, the Himalayan mountains. Now, these Himalayan mountains are virtually a kind of a lifesaver for India. Himalayan mountains, which dot the country across the northern frontiers, they have not only shaped the climatic conditions, they have shaped virtually the lifestyle and the feeding habits and the entire economy of the region. First of all, they feed hundreds and thousands of various different rivers and streams, which provide or which are life-giving source for millions of people who depend on them. Secondly, they protect us from very cold seasonal winds which originate from the northern portion around Siberia, and they end up hurtling towards the region of Himalayas. The Himalayas, they act as a barrier. Traditionally and historically as well, if you take a look at the role played by Himalayas in our society, in our country, in our landscape, they have acted as a natural protector of sorts. Be it the Huns, be it the Mongols, none of the invaders could venture into India, could even dare to venture into India, precisely because of the protection provided by Himalayas. But when we talk about the climatic condition, the climatic divide, here you have to understand that if you take a look at the territories in the same region across a similar latitude, you'll find majority of them are deserts. For example, take a look at Iran, take a look at the Arabian Peninsula, take a look at Africa. Now, all of these are traditionally deserts, but India has got a very limited portion of desert, but otherwise, India is very agriculturally productive and receives a lot of rainfall. And all of that is because of the role played by Himalayas. How? So when you have rain-bearing winds which enter from the region of, let's say, the Arabian Sea, now these winds are obstructed and blocked by the Himalayas. So is the case with the winds coming from the region of Bay of Bengal, the moist winds. Now, if the Himalayas would not have been there, these winds would have very easily crossed northwards. But the presence of Himalayas means or ensures there is significant amount of rainfall caused in various different parts of the country. And that is very, very important in maintaining the moisture level and in ensuring the region doesn't turn into a desert. Again, as I said, that during the winter season, these Himalayas are also responsible for bringing winter rain and winter precipitation in the northern part. But more than that, you will also come across the fact that during the winter months, the seasonal cold winds which are coming from the region of Siberia, they are also blocked by the Himalayas. So the Himalayas are a kind of a true life giver in terms of the Indian subcontinent. That is why UPSC tends to ask you questions from this part also. UPSC tends to ask you questions about what is the role played by Himalayas in Indian subcontinent. Now, when you have such kind of a question, role played by Himalayas, you cannot restrict your answer only to the climatic condition. You have to talk about Himalayas forming a natural border, providing security. You have to talk about the rivers. And then you also have to talk about the climatic condition, the ecosystem, the very different and unique kinds of vegetation that Himalaya has to offer. Everything has to be talked about. Okay? Now, then the other factor is the relief. Relief basically ends up meaning a kind of a topographical feature. Okay, so that basically indicates a kind of a topographical feature. Topographical feature. So across the country, you have a very varied kind of relief features, from the escarpments of Western Ghats to, when we talk about, let's say, the presence of Vindhyas and Satpuras, to the presence of northeastern mountains, to the Himalayan feature. We have very unique kind of relief features prevalent across the country, and that aids the occurrence of rainfall, or maybe a region not receiving rainfall as a consequence, as a result of it. For example, when we talk about any relief feature, while we have studied this earlier as well, let's suppose when we talk about the common occurrence, let's say, of an orographic rainfall or rainfall caused because of a mountain. Now here, the side of the hill or the mountain which faces the wind, that is what is the windward side. That is the windward side. And the other side is the leeward side. Right? Now, here the windward side will force the winds to rise up. They will lose temperature, they will cool down, and they will cause copious amount of rainfall as a result of it. But then the winds, they become dry, and the leeward side does not receive rainfall. So this entire region on the leeward side of any relief feature which does not receive rainfall because of the relief feature, that is also what is referred to as the rain shadow zone. rain shadow zone. So the relief features, they will basically provide a direction to the wind movement. The relief features will also provide a kind of a availability of excess rainfall or higher than average rainfall in certain areas, concentrated rainfall in certain areas, for example, Western Ghats and so on. All of that is basically dependent on the relief. So for example, windward side of Western Ghats and Assam, they receive very high rainfall, for example, Cherrapunji in Meghalaya, whereas the southern plateau remains dry because it is in the leeward position of the Western Ghats. Another example, if you take the case of Cherrapunji, Mawsynram and Shillong, the region which receives the highest rainfall across the planet, that is Mawsynram. Now, Mawsynram, on an average, receives close to around 1140 centimeter of rainfall every year. That is the amount of rainfall received on an average in Mawsynram. Now, 140 kilometers or around 100 kilometers away from Mawsynram, you have Shillong. And Shillong basically receives around 120 to 130 centimeter of rainfall. So how is that possible? While Mawsynram receives so high amount of rainfall, a nearby location or a nearby region that receives only around 130, 140 centimeter rainfall. That is because Mawsynram, Cherrapunji, they lie on the windward side, whereas Shillong lies on the leeward side. So that is why relief features are very relevant. In fact, the alignment of relief features also mean that Rajasthan ends up being a desert. Had the Aravallis got a different kind of alignment, Rajasthan would not have been a desert, but in that case, Punjab and Haryana would have been a desert. So that is where the relief features, they shape the rainfall distribution across the entirety of the planet. If you take a look at this rough map here, a rough depiction of map, so to say. So here you have the Himalayas, the chain of mountains, and the mountain ranges which are present. Now, here, if you observe, first of all, the moist winds, the moisture carrying winds, they come from the region of Arabian Sea as well as from the region of Bay of Bengal. Now here, first of all, they will hit the Western Ghats. As they hit the Western Ghats is an escarpment. That means it will have a very steep wall-like feature. So that is where suddenly the winds are forced to rise up, causing very heavy rainfall. One of the second most rainiest area across the planet and across the country is Agumbe on the western side of the Western Ghats. Now, that means this particular region otherwise would be dry, right? Because it is on the leeward side. But there are certain gaps in the Western Ghats as well, as we will study later on. There are certain gaps in the Western Ghats, which means through those gaps, wind is able to penetrate, causing rainfall in areas such as Nashik, in areas such as Pune, in areas such as Bangalore, providing much relief in these regions. Now here the Vindhyas and the Satpuras, for example, they provide a kind of a passage of wind. Observe here, they form a kind of a narrow corridor through which the moist winds from Arabian Sea, they are able to reach directly the portion of central India, and they cause a lot of rainfall in that region. Otherwise, that region would have been dry, completely dry. Now, the alignment of the Aravallis here, for example, when the winds move, now the Aravallis, they form an obstruction only in the southern edge. So there, they will cause rainfall in the southern part of Rajasthan. That is why southern part of Rajasthan is not very dry. Whereas for the rest of the region, the Aravallis are largely parallel to these moist winds coming from Arabian Sea. So the winds, they straight away pass through this region. They hit the Himalayas, cause rainfall in this area. On the other hand, if you talk about the moisture winds and the moist winds coming from the region of Bay of Bengal, they immediately hit the region of the Himalayas. And it is the Himalayan topography which directs the winds. Some part of it goes in the northeastern region, where it gets entrapped in the various different funnel shape of mountains and the funnel shape of hills which are created. The winds will get trapped here unless and until they are drained of all the moisture that they are carrying. They will continue to cause rainfall in that region. Some amount of those winds, they are deviated along the foothills, and they then cause rainfall across the various different paths. It is this directionality which is given to the Bay of Bengal branch. That directionality basically pushes the wind across the western part, and that is what causes rainfall in the central part of India as well. So that is how the relief features purely they are able to determine, or they are able to influence the various different climatic conditions that we experience, the distribution of rainfall, the intensity of rainfall, the amount of rainfall, during which part of the year do we receive rainfall. Everything is determined by the relief features. Now, due to Himalayas, Tibetan region does not suffer. Tibet is a very high altitude plateau. In that high altitude plateau, generally, you have drier conditions which are prevalent, right? Had the Himalayas not been there, let's suppose, so if in that case, the Tibetan region would also not have been there because the formation is very similar. But let's suppose Himalayas were not there and Tibet was there. So that would have provided a kind of again, an escarpment of sorts where southern part of Tibet would have received very heavy rainfall, whereas the rest of the region would have been dry. For example, take a look at the plateau region in southern India. You have the region of Karnataka, Maharashtra, Telangana, Andhra Pradesh, all of them. They are very, very dry in conditions of rainfall. Okay. Now, after this, we have a unique distribution of land and water. India is referred to as a peninsular landmass or a peninsula. Peninsula means a land surrounded by water from three sides. That is why it is also referred to as Indian Peninsula or the subcontinent peninsula in general. It is surrounded by landmass from three sides. Now, this has got varying impact and effects. So here, the first impact is that we have a very long coastline, and the coastal areas will experience extremity of temperature or moderation of temperature. What do you think? What is experienced in the coastal area? Extremity of temperature, or is there a moderation of temperature which is experienced? Good. Coastal areas experience moderate temperature. You will never find the extremity of climatic conditions to be prevalent across the entirety of peninsula, across the entirety of the coastal area. It is a different matter that just to make ourselves happy, we start burning logs of wood during the months of January, that it is winter season. Ideally, everywhere across the world, people are wearing sweaters. So we also need some bonfire. So that is a psychological aspect, which is a different matter altogether. But if you talk about the winter season in the entirety of the coastal India, winter season is largely the one where the temperature is around 20 degrees, 21 degrees, 18 degrees, and so on. If somehow the temperature drops to 17 or 18 degrees Celsius in the peninsular part of India, panic strikes. And if, let's say, it reduces to around 12, 13 degrees Celsius, people start panicking beyond anything. That this is the coldest condition that we have encountered. This is not how the world is supposed to be. We need heaters. We need all the various different instruments. But cross the Tropic of Cancer once and move to the northern part. You will come across the winter season, where the winter season is very frequent. For example, Churu in Rajasthan, from the month of late November itself, it starts indicating 2 degrees Celsius, 1 degree Celsius on the mercury scale. And then again during the summer season, the northern part of the country, they will be roasting in summer, because even right now, all of you who are from the northern part of the country, who are placed or situated in the northern part of the country, you would be experiencing oppressive weather conditions. The temperature soaring up to 42, 43, 45 degrees Celsius. It gets much worse. So that is where the coastal areas, they benefit from it, right? And then, because why? You have the frequent land and sea breeze. Frequent land and sea breeze. Then after that, the other impact is during the summer season, when, let's say, the land mass heats up quite significantly. The land gets very heated up during the summer season. So in the summer season, when the land gets heated up, you have a low pressure. And we know that during the summer, water is comparatively cooler as compared to land. So water becomes a comparative high pressure, land becomes an absolute low pressure. So that is why after prolonged heating, when the land becomes an active low pressure, moist winds from the nearby water bodies, Arabian Sea and Bay of Bengal, they come and they bring rainfall, providing much relief. If, let's say, there would have been land areas around us, then we would never have received that rainfall. So during the summer, when the land becomes very hot, intense low pressure, the cooler waters supply winds, moist winds, which bring rainfall. Okay, so that is where the aspect of land and water having this kind of a distribution, that is very, very conducive, and that is something which is very, very helpful as well. Okay, what about Western Andhra and Telangana? Is it cold there? It is not very cold. See, cold is also a kind of a subjective term. What is it that you would regard as conditions of very cold? So, for example, if, let's say, somebody from Punjab comes over to the region of Telangana during the winter months, they will not experience very cold conditions. However, Telangana and Western Andhra in comparison, and also Vidarbha region in comparison to the southern part and other parts of peninsular India, they are comparatively colder. And the reason is very simple. These are drier areas. And wherever you have a drier area, that means what? You will have a very high lapse rate. The loss of heat will be very quick in the drier areas. So that is where during the winter season, these regions still, sometimes you will come across the mercury reading of 10 degrees Celsius, 12 degrees Celsius during the winter months. But that is also very rare. Okay. Now, then we have the factor of altitude. Now, different places across the country, they are not at the same altitude, obviously. They have different altitudes. So, temperature, rainfall conditions, everything ends up varying with the level of altitude. For example, take the very famous case of Agra, Darjeeling. Both of them situated at a similar latitude, but one of them is situated around 100 meters from sea level. Agra is around 171 meters from sea level. Darjeeling is around 2000 meters above sea level. So that is where in Darjeeling, in the month of January, you experience a temperature of 4 degrees, and Agra averages 16 degrees Celsius. Right? Similar is the case, for example, if you consider, let's say, Ooty and Chennai, very close in terms of latitudinal distribution. But Chennai, while it suffers from a very oppressive heat and very oppressive hot conditions. On the other hand, Ooty is very, very pleasant owing to the altitude aspect. So altitude is again an important factor. So what are the various different factors that we have talked about? We have talked about the location, that is a latitudinal position. We have talked about the relief features, the Himalayan mountains, the land and water distribution, as well as the factor of altitude. Now, after we have familiarized ourselves with this basic concept, now we shall be introducing ourselves with the factors which will influence and which tend to influence the Indian monsoon. So what are the factors which influence the Indian monsoon? Let us take a look at that. Each of these factors, by the way, we shall be approaching one by one. Each of these factors, we shall try to understand it one by one. And after that, we shall be weaving a story around the entire concept. Having said that, for each of the factor, I have provided a significant written amount in the PPT itself so that your job becomes much more easier, so that whatever pen that you are using, you should not use that. Just try to observe it. Try to understand what is happening. Try to understand how a particular factor is bringing rainfall or is inhibiting the causation of rainfall. Because once you understand these factors individually, then the entire aspect becomes easy. So the major factors, the differential heating and cooling of land and water, which creates the low pressure on the land, the shift in the position of the ITCZ during the summer and the winter season, the subtropical westerly jet stream. Yesterday we had talked about it, that how it splits over the region of the Himalayas. Now this is very relevant for the onset of rainfall, onset of monsoon. Onset of monsoon is determined by the subtropical westerly jet stream. So nowadays, when you start reading in the newspapers that the onset is delayed, onset is advanced, onset is going to be on time, all of that is determined by this single factor. Because by this time of the year, moist winds already start approaching Indian coastline, but they won't cause rainfall unless and until they are given a green signal by this subtropical westerly jet stream. Then we have the heating of the Tibetan plateau during the months of April, May, and some parts of June, which brings into circulation a temporary jet stream, that is the tropical easterly jet. And that gets into circulation during the later half of June, the last week of June and July. This also benefits the Indian monsoon. Then you have the mascarene high. Now, what is this mascarene high? This is not a highland. These are mascarene islands, a plateau sort of region which is situated in the southern Indian Ocean near Madagascar. So this is the high pressure near Madagascar. Now this high pressure supplies winds which traverse across the oceans and they come to the Indian coastline, bringing the much needed rainfall. Now, how is it that this high pressure cell is responsible? So we have seen in the case of atmospheric circulation that rather than pressure belts, we have pressure cells and pressure zones, which are supplier of the winds. So this mascarene high pressure is a supplier of the southern trade winds or the southeasterly trade winds. They are supplied from the region of mascarene high. So strength of mascarene high, whether the high pressure is significantly intense or not, that determines the amount of winds coming to India, and that determines the amount of rainfall received in India. So stronger the high pressure, more winds in India. Weaker the high pressure, less winds received in India. Then El Nino Southern Oscillation and Indian Ocean Dipole, they can always end up influencing the amount of rainfall received in India. Okay, they can interact with each other, they can cancel out each other. Okay, Utkarsh, Even Madagascar plays a role in monsoon. Not exactly Madagascar. Mascarene Islands is situated near Madagascar, so that has got a role to play. So now we start with each of these factors one by one. Now, starting with the heating of land. So, during these months, that is, the months all the way from the late March itself, March, April, May. Now, during all these months, especially across the northern parts of the country and also the central part of the country, you would have experienced that there is intense heating. Intense heating in the sense that you have the temperature soaring around 40, 42 degrees Celsius, 43 degrees Celsius. Rajasthan, the Thar Desert, very intensely high temperature. The northern plains, very intensely high temperature. Vidarbha, Telangana region, very high temperature. That creates a very active low pressure. Comparatively, the waters are cooler during the summer season. The waters are generally in a comparative manner, they are generally cooler. So that is where you have a comparative high pressure. Comparative, not intense high pressure. This high pressure is much lower than the high pressure at Mascarene Islands. So from Mascarene Islands, if you take a look at this will also be a low pressure. But comparatively to the ground, it is high pressure. So you have moist winds coming from here, bringing rainfall. In fact, this was the first explanation provided for monsoon. And the first explanation provided for monsoon was, look, during the summer season, the land becomes extraordinarily hot. And that is where the nearby water bodies are cooler in comparison. As a consequence, cooler moisture-laden winds from the water bodies, they hit the landmass, causing rainfall. But later on, people came upon the realization that this is not the only factor. You have many other factors which are at play, which are involved in causing rainfall in India. So here, let's take a look at the other very important factor. In fact, when we talk about heating of land mass in general, so here you will observe, for example, recently, that is around a week and a half back, last week almost, you would have observed, all of you belonging from the region of central India to some parts of southern India, around the region of, let's say, Andhra Pradesh, Telangana, also parts of Karnataka, you would have experienced very heavy rainfall, thunderstorms. And so is the case with the region of Bengal, Odisha, Jharkhand as well. Why? Because you had very intense low pressure cells, almost cyclonic cells, which were formed here and here. So this attracted winds immediately and they brought rainfall. So the heating of the landmass is very imperative to be able to bring rainfall in these particular regions, in these particular areas. Then we have the shift of the ITCZ. ITCZ, which tends to shift overall. Now, ITCZ shifts in between the various different seasons. Ideally, ITCZ should lie at equator, but ITCZ is nothing but thermal low pressure. In that region, the absolute thermal low pressure which is present. So, it is absolute thermal low. It is the case of an absolute thermal low. Now here, this absolute thermal low pressure, what does it mean? So it basically means that here you have very intense low pressure created wherever the ITCZ is passing through. So here you would observe that in between the various seasons, the ITCZ does cross over India. During the month of January, December and January, this is the location of the ITCZ. During the month of June, July, observe ITCZ passes through all the region, the Sahara Desert, the Arabian Peninsula, and also over the portion of the northern part of India, Thar Desert, northern plains, and so on. Why? Because there is so much heat. On an average, the temperature exceeds 40 degrees Celsius. That is why It is the absolute thermal low. Now, when the ITCZ is passing through the northern parts of India, what is the consequence of it? What is the result of it? So, for example, let's suppose we consider this. Let's suppose we consider the shifting of ITCZ here. So, here, let us take the example. And first of all, the first thing that you should do is draw the rough equator. Suppose this is the equator. Now, yesterday, even though we had talked about it briefly, that the ITCZ does shift over the part of the country, some part or the other. Here, during the months of May and June, ITCZ lies over here in the northern part. So, ITCZ during the month of May and June, that comes over here, roughly. It is a broader zone, it is not a thin line. But this does not reach there all of its own in one day. In the month of later March, it will start progressing slightly north in this particular portion. In the month of April, it will move over this area. In the month of early May, the season that we are in, the ITCZ is roughly around this particular region. That is why here you would observe cyclonic circulation developing in the region of Bay of Bengal. That has been named as Mocha. Sometimes circulations develop in the region of Arabian Sea also during this time. Now, this is the position of the ITCZ. Now, ITCZ is what? ITCZ overall, as we have seen in the tricellular model of circulation, ITCZ is a place where you have the convergence of winds. That is the Hadley cell. That is the Hadley cell. Right? So you have, if this is the ITCZ, this is the subtropical high. Subtropical high. In the case of Indian monsoon, what is the subtropical high? It is around the Mascarene Islands. We'll come to it. And these are your trade winds. Same is the case with the northern part also. Now here, because the ITC that has shifted north, the subtropical high in this case is provided from the Mascarene Islands. Mascarene Islands. That means what? From here, winds will start coming. Here, winds will start coming. Right? Their destination is what? Their destination is ITCZ. All the winds from the southern hemisphere, they will start coming. Mascarene Island is situated here roughly. If I show you the exact location of Mascarene Island, observe, if I have to show you, these are the Mascarene Islands, observe. These are your Mascarene Islands, okay? Now, furthermore, here, basically, the winds, they start coming in general from the region of the subtropical high. They will cross the equator and then they will bend to the right. Why? Because of the Coriolis force. They will bend to the right. Due to the shape of the Indian peninsula, the winds will get divided. One part goes into the region of Bay of Bengal. Here you have fold mountains in Myanmar in the form of Arakan Yoma, Pegu Yoma, Tanasare mountain ranges, which are situated across the bordering regions of Myanmar. So these will hit them, and then they will be diverted towards the region of Bangladesh. Now, all these winds, their ideal destination is to reach ITCZ. But in the process, they have covered hundreds and thousands of kilometers over the ocean. So what will be the moisture condition of these winds? They are heavily loaded with moisture. That is why they are able to bring so much amount of rainfall in general. Okay, so that is why they bring very heavy rainfall. Now, what is the direction that these winds have? When they approach India, what is the direction that they have? You will observe the direction is southwest to northeast. That is the direction, southwest to northeast. And the winds, they are named owing to the direction in which they originate or they come from. That is why these winds, which is the advancing monsoon, that is what is referred to as the southwest monsoon. Southwest monsoon. Because the direction of the winds are from southwest to northeast. Okay? So here, the ITCZ is the zone indicating lowest pressure in the tropical region. It is in this zone that winds from both the tropics will converge. The ITCZ moves north and south with the apparent movement of the sun. During the monsoon months, the ITCZ does pass through northern part of India. The ITCZ attracts winds all the way from southern subtropical high pressure belt in general, and that is where look at the direction of the wind movement. This is the satellite image of the wind movement. Observe the wind movement here. Now here you will observe that in the southern hemisphere, the winds are getting supplied here. Right? Now, this is the region of the entire high pressure zone. This is also another high pressure zone. All these are high pressure zones. Because remember, during the monsoon months, that is the month of May, June and July, what is the season in southern hemisphere? Is the summer very oppressive during these times, or do they experience a different season? Good. During these months, it is winter season in southern hemisphere. I hope we are aware that when it is summer in north, it is winter in south and vice versa. So during these months, it is winter season. So naturally, high pressure cells will be very stronger. So observe the wind movement. Observe how that immediately when they cross the region of equator, they start bending to the right. They traverse here, and that is how they enter India. Okay, this is something that you can also look at it on your own on a daily basis. This is something which is updated on a real-time basis. So you can actually go to the website, you can actually search and look at it, that what is the wind. If you are interested, if you have time, you can always look for it, that what is the wind movement which is happening. That helps you understand a lot of part about which area is experiencing what kind of condition. For example, here if you observe, just to give you an indication of it, if you observe this particular region here, this entire region, here, just by looking at the image, you can conclude that this is a very strong anticyclone created. Why? Because you have origin of winds. Winds are originating from here and moving in different directions. So this is a very strong anticyclone created. So that is basically just by looking at the wind map, you can gain an idea. But nonetheless, due to the shift of the ITCZ, the winds are dragged all the way to the northern hemisphere, all the way across India, and after crossing the large water body, that is why they are very laden with moisture, very heavy with moisture. Then we have the subtropical westerly jet stream. Now this is the jet stream which moves over to the Indian region. Now this jet stream, virtually if you take a look at this jet stream, basically, this is the jet stream which moves generally like this. Now, as it encounters the Himalayas, that is where it gets broken into a distinct northern branch. And also, just to show you the kind of a schematic, it is not always interlinked like a river tributary, but just to show you the schematic, this is how it eventually breaks into a northern branch and into a southern branch. This is the subtropical westerly jet, and this is the northern branch. And this is your southern branch. Now here, when we talk about these jet streams, we have seen yesterday that jet streams, they are formed at the region of where the pressure belts are, right? Immediately above the regions of the pressure belts, that is where the jet streams generally are created. Now, during the various different seasons and various different months, the pressure belts, they shift. So the jet streams, they also shift, right? So just like the pressure belts shift, the jet streams will shift with various seasons. So jet stream shifts with various seasons. In the sense that it shifts north. It shifts north when? During summer. And shifts south during winter. Now, these jet streams, they are unable to scale the Himalayas. They are unable to cross over the Himalayas. That is why they get bifurcated into a distinct northern and the southern branch. During the winter months, the southern branch is particularly strong. Most of the jets and most of the winds carried by the jet, that will move across the very distinct southern branch, which moves over the central part of India, which sometimes moves over the region of Maharashtra, Telangana, some parts of Andhra Pradesh as well. So that is very prevalent. But slowly and steadily, as the jet stream starts to shift north, it begins from the region of Mediterranean initially. So here, the jet starts shifting north. Now, as it starts to shift north, the northern branch, that will start to get reinforced. Northern branch starts getting stronger. Whereas the southern branch starts getting weaker. Ever so slowly, with each passing day, the supply of winds to the southern branch, that starts reducing. Even the southern branch, ever so slightly, that also indicates a shift slightly to the north. Not very distinct, but slight movement to the north is experienced nonetheless. And it grows weaker by the day. It grows weaker. But as long as you have the southern branch of jet stream, yesterday we had seen that jet stream, that doesn't allow the movement of air. So as long as you have the southern branch of jet stream passing through the central portion of India, India will not receive rainfall. Some pockets might receive rainfall here and there, but monsoon is not said to have arrived in India. Why? Because think about it, let's suppose this is the jet stream in the northern portion. I'm sure many of you will have the question, jet stream is in the northern portion. Till that point of time, can we finish up rainfall in the southern part of India so that when the jet stream disappears, rainfall can also come to the north? But that is not how it works. If let's say you have the jet stream here, now the winds, let's suppose this is the landmass of India. This is where you have the Arabian Sea. If the jet stream is placed here, it will not allow the movement of air even in this part. So the air is blocked. Then the air means this portion will also have the blocking of air. Means this portion will also have blocking of air. This means this portion will also have blocking of air. That means even over the water body, even if the winds have arrived, they have the air which is blockaded. Imagine like you are standing in a traffic jam, right? And a traffic jam is 2 kilometers in front of you due to a signal. You have a traffic jam. Let's suppose here you have a traffic jam, right? And this extends all the way up till 4 to 5 kilometers, right? Now you have to reach here and you are here. So if you have a question that traffic jam is at point A, I have to reach only B. Why don't I reach B? You can't, because the other vehicles are also in the line and the other vehicles are unable to move. Unless the other vehicles will move, you will not be able to move and you will not be able to reach B at all. So something very similar is at play here as well. Unless and until the jet streams themselves disappear, the wind movement will not be initiated. The moment the jet stream disappears, all the winds, they appear to be free, and suddenly they will rush in. And suddenly, even in the coastal region, these will rush in. And that is when the onset of monsoon is declared, first of all, in the region of Kerala, the Kerala coastline. So that is how these jet streams, as long as the southern branch is there, will never let monsoonal rainfall occur in India. The moment southern branch starts weakening, till one day finally it disappears. And that is when the onset is said to have happened. Okay, so this is the role played by the subtropical westerly jet stream. So here, subtropical westerly jet stream, basically these are the jet streams which tend to develop over the region of the subtropical high pressure belt. During the winter months, these jets, they lie over the northern part of Indian subcontinent, having a distinct northern and the southern branch. With the onset of summer season, as the ITCZ in itself shifts north, the jet stream accordingly will also shift north. But that shifting will mean that ever so slowly and slightly, the southern branch of the jet starts weakening till one day it will disappear, right? So the southern branch of the jet stream starts weakening. But as long as the southern branch is there, it will not allow the onset of monsoon. The moment it disappears, the moment it disappears, onset, or rather, wind movement is initiated. Wind movement is initiated, and onset of monsoon is observed. Okay, that is the role played by the subtropical westerly jet stream. Then you have another temporary jet stream which is at play. Okay, meanwhile, I have few questions. Which portion you have not understood, please ask that rather than please repeat the entire thing again. Always, I would request you, please ask which is the portion you have not understood. It cannot be that you have not understood what is the meaning of subtropical westerly and what is the meaning of jet stream. So, which is the portion that you have not understood? Please pinpoint that. So, few questions. Utkarsh, the low pressure created by southern part of India holds a major part of rain in India. No, the distinct low pressure is created in the northern part. Okay, a very distinct low pressure is created in the northern portion of India. That is where the ITCZ passes through. So that is where majority of the rainfall is observed across the entire month. Then I have a question from Dinesh. Are jet streams and low pressure zones interlinked? No, absolutely not. Absolutely not. They will. Why will they be interlinked? Okay. Then I have a question from Purnesh. Why jet streams so high? As in the altitude, if you are asking that why jet streams, they are existent at such high altitude, because jet streams in themselves, they are created because of pressure difference and the pressure gradient force created at higher altitude. Yesterday, we had talked about the formation of the jet streams. So there you can look at the annotations of the PPT, you'll get an idea. And Chandrakant, why only after disappearing of the southern branch? Okay. That is where we had talked about that as long as the jet streams are present, they don't allow the air to intermix. Now, how many of us present here, we did not attend the session of jet streams yesterday? Please be very frank, because we can see the names and we get an idea. How many of us, we have no clue about what are jet streams, and suddenly we are finding ourselves in the muddle that we are talking about the subtropical westerly jet stream, we are talking about the movement of the jet stream, and so on. So all those, I understand that you might have some or the other issue, some or the other engagement levels, but please take a look at the annotations of the PPT. You will get an idea about how they are created. And there we have affixed an image in the annotation as well, which tells us that the Himalayan mountains, they offer a kind of a barrier for the movement of the jet streams. That is where you have a distinct northern and the southern branch which develops. Okay. Uh, Prashant, I'll show the text portion, don't worry. Starting off subtropical jet stream, that is the problem. Okay. Aarti, due to shifting of belt, jet stream is also shifted how? Okay. Dinesh, because you said when ITCZ moves up, jet stream moves up. Okay. Yera, did Western Ghats receive more rain or Eastern Ghats? Western Ghats, Yera always. And Pranay, rains before onset is independent of jet streams. Yes, rains before the onset, that is independent of jet stream, that is independent of monsoon also. That is pre-monsoon showers that you start receiving. And sometimes due to low pressure also you start receiving rainfall. Okay. So for all those of you who have not attended the session of Jetstream, see, I cannot completely start revising the entire portion of Jetstream right now. That will basically take away this topic itself. So I would suggest to you, I would request to you that kindly look at the formation of the jet streams from the annotations of the PPT, from the recorded video. You will get a clue that where these jet streams are formed, what are these jet streams. So overall, we have seen yesterday, what we have basically seen is that across the planet, you have 4 permanent jet streams that is formed in areas. And don't worry about it. Many of them who have attended, for them also the concept is not clear by looking at the questions. So even those who have not attended, don't get disheartened by it. You can still understand this topic. So by looking at the questions, I can understand that many of us who have attended, even their concept is not clear. So here, let's suppose In the tricellular model of circulation, what is it that we had seen? We had seen basically that over the ITCZ, this will move, right? You have the Hadley cell. This is where the subtropical high pressure is created. Then you have a subpolar low. And then you have a polar high. Right? This is the tricellular model of circulation. Now, jet streams are created in the upper atmosphere, in the upper region of tropopause or troposphere, wherever there is a distinct temperature difference of the air parcel. So here, we don't have a temperature difference because both of them are tropical air. So we don't have any temperature difference. Here, we have a distinct temperature difference because one of the winds is coming from the region of equator, the other wind is coming from the region of 60 degrees. So here you have a jet stream which is prevalent. And this is the subtropical jet stream. Subtropical jet stream. Then here, again in this portion, one part of the wind is coming from the polar area, other part is coming from the tropical region. So here also you have a very strong jet stream which is created, which is referred to as the polar jet. Polar jet stream, right? Now these are your pressure belts on the ground surface. These are the pressure belts. So you will find that these jets, they are placed over the pressure belts more or less. Now, these pressure belts, they shift. They will shift between the seasons. For example, let's say this is the northern hemisphere. This is the southern hemisphere, let's suppose. So, during the winter in the northern hemisphere, all these pressure belts, they will shift to the south. This will shift slightly here. Why? Because the ITCZ shifts south. So if the ITCZ shifts south, this pressure belt will also slightly shift south. This pressure belt will also slightly shift. And so along with that, the jet stream will also shift. In this case, slightly to the south. This jet stream will be prevalent here. Now, come the summer season, all the pressure belts, they will shift north. So basically, when the ITCZ starts shifting north, here, this subtropical high pressure belt, that will also shift north. So with the northward shift of ITCZ, the subtropical high pressure belt also shifts north. The subpolar low pressure belt also shifts north. That means the jet stream which is formed above them, they will also ever so slightly shift to the north. So now, with this basic concept, let us come back to this again. When we have the jet stream, that jet stream shifts with the various seasons. Why? Because of the shifting of the pressure belts. And the pressure belts are shifting. Why? Because the ITCZ starts to shift. So as the ITCZ starts to shift to the north, the subtropical high pressure belt will also shift to the north, which means this jet stream will also slightly shift to the north. Now, in that situation, here, let us think about it again from scratch. Now, during the winter months, the jet stream, let's suppose, is like this. A very distinct southern branch and a weaker northern branch, right? This is the northern branch and this is the southern branch. Now then, as the summer starts to come, this jet stream will start shifting ever so slightly. This jet stream will come here. As the summer comes, the pressure belts will shift. This jet stream will come here. The northern branch will get much stronger. Southern branch will come here. This northern branch will start strengthening because the entire supply is from the northern branch. Southern branch will still be present but will be weaker to ensure the continuity of the flow of the winds. Right? Now, the month of April passes. The temperatures are very high. In the month of May, now almost the ITCZ has also come here. So the jet stream has to be above the subtropical high pressure belt. Ideally, the jet stream is not above the ITCZ. The jet stream is above the subtropical high pressure belt. But if the ITCZ significantly shifts, the jet stream also will shift. So the southern branch, what do you think will happen? If let's say this is the Himalayan mountains, here you have the northern branch, here you have the southern branch. Can the southern branch climb over the Himalayas and reach the northern branch if everything is shifting north? They cannot do that. Because if they would have had the ability to cross over the Himalayas, they would never have got bifurcated. The only reason that the jet stream has got a distinct northern and the southern branch is because there is an obstruction, a physical barrier offered by the Himalayan mountains. That is why it has got a distinct northern and southern branch. Now, in this situation, slowly and steadily, the jet stream will further move north. It will further move north. It will strengthen the northern branch, and every passing day, the southern branch starts to weaken. The southern branch, it starts to weaken, it starts to thin out, it becomes irregular in general. But as long as the southern branch is there, whatever small presence of southern branch is there, till that point of time, these jets, they will not allow the passage of air. Why? Because they offer obstruction in the higher atmosphere. So if let's suppose this is the landmass, if this is the jet stream, it is not as if very sneakily air can sneak underneath them. Because when you have air movement, it has got a vertical column as well. So the entire movement is blocked. So as long as you have any part of the southern branch which is present, even if the moist winds and the moisture laden winds, they have approached the Indian Ocean and approached the Indian landmass, they will not be able to enter into India. Why? Because there is a long traffic jam created in the upper atmosphere, and due to which the wind movement, there is a very long traffic jam created. Now I bring you back again to the analogy. Let's suppose a traffic jam is created in this portion. In this portion, if a traffic jam is created here at point A, does not mean that up till point B, the vehicles are free to move and go where they want. No. If the traffic jam extends all the way for 5 kilometers, regardless of how major and important person you are, or whether your house is only 2 kilometers away, you will never be able to enter your house because there is a long traffic jam. Similarly, these jet streams, they create that kind of a traffic jam in terms of atmospheric movement, and they won't allow the entering of the air into the Indian subcontinent. Then, all the meanwhile, the Indian landmass is getting heated up. And that means the ITCZ is shifting north. That means the subtropical high pressure belt is also shifting north. With the shift of the subtropical high pressure belt here to the northern part, the jet stream will also be moving to the northern side. So as the jet stream is slowly and steadily being pushed to the north, it will strengthen in the northern portion. The supply to the southern branch will keep on getting weakened. And eventually, one fine day, this jet stream will completely, the southern branch will completely disappear. It will reappear again during the winter months. It will start reappearing again during the month of September itself, late, sometimes October, sometimes even late September. But all the meanwhile, the moment the jet stream disappears, that is the moment, imagine as if in a small classroom, as long as the teacher is there, as long as your class teacher is there, everybody is silent. The moment the teacher leaves, look at the freedom, the joy, the independence that the students, they feel. So imagine that the winds have that kind of a freedom or independence. They start rushing in. And all the winds from here, first of all, which was created due to traffic jam, these winds will move. So when these winds will move, they will immediately, because the upper air obstruction has been removed, so they will start rising up, they will start the process of convection. In the meanwhile, as these winds will move, the traffic jam which had stopped the moist winds in the Arabian Sea, these will also start rushing in. They will hit, first of all, the Kerala coastline. They will start bringing incessant rainfall or a continuous rainfall for 5 to 7 days. And that is when we declare it is the onset of monsoons in India. So overall, if you take a look at it, these are the jet streams, the subtropical westerly jet streams. These are the jet stream. This is the subtropical jet stream. Why westerly? Because it moves from west to east, which tend to develop over the region of subtropical high pressure belt. Now, during the winter months, these jets lie over the northern part of Indian subcontinent, having a distinct northern and the southern branch. With the onset of summer season, as the ITCZ in itself shifts north, that means the subtropical high pressure belt will also shift north. That means the jet stream will also shift north. That means the southern branch will start weakening. The moment it disappears, wind movement is initiated and onset of monsoon is observed. Is that clear? Or do we have doubts? Any doubts, feel free to ask. Purnesh, do you have the doubts? Dinesh and Sai Babu, please let me know. Prashant, you also. Let me know if the doubt prevails or is that clear. So I'm assuming that the doubt is clear. Okay. Or the other case can be that you have lost hope, that now it is beyond my reckoning, something that I cannot understand at all. So if that is the case, please point it out, right? Otherwise, if it is required, let me know which portion is not understood. Rather than simply saying explain the whole portion once again. In the meanwhile, I will get my lunch ready and so on. Rather than that, please point out which portion. See, also understand, even for your understanding, for various different subjects, never have the approach that the entire process is not understood. Always think about it, that which portion in particular is not understood. It will help you find solution as well. Coastal areas experience only rainfall, or northern part will also be experiencing rainfall? Northern part will also experience rainfall. It starts with the coastal area and then slowly and steadily, very quickly, as this disappears, very quickly from here also, moist winds will enter, and simultaneously these regions, they will start receiving high amount of rainfall. Okay? Right. Now we come to the portion of heating of Tibetan Plateau. Okay, why does it move north of Himalaya after weakening and movement of ITCZ? Where will it go, Binita? Think about it. Where will the jet streams go? If not to the north of Himalayas, where will it go? It has got no other place. It is not as if that it will be restricted to Pakistan, that this time Pakistan, you manage the jet stream. Next year, we will also receive jet stream. That cannot happen. So as the entire pressure belts will shift, observe this image. As the entire pressure belts will shift, that is why these jet streams will also shift, because they are interlinked with these pressure belts. Okay. So as the pressure belts start shifting, that is where the jet streams also start to shift. Is shifting of ITCZ due to El Nino effect? No, absolutely not. It is due to heating of land and water. Why is there a jet stream to north only? That thing is not understood. As in, do you mean to ask that there should not be a northern branch at all? Or do you mean to ask that why there is a, what is the exact question that you're trying to ask, Dinesh? Please reframe your query. And don't worry about it. Why shifting? Okay. See, this is the jet stream. First of all, understand this is the subtropical jet stream. Or let me use another image. So this is the planet, this is the equator. Now here you have, let's suppose this is the subtropical jet stream, right? With the shifting of the pressure belts, this jet stream will move north during the summer. It will move south during the winter. I hope that portion is clear. When we say shift north means it will shift north from its position. Shifting south means it will shift south from its position. I hope that is understood. Now, the jet stream in general is not as regular as you see in the image here drawn. Jet streams, basically what we had also covered yesterday, is that the physical barriers in the form of Himalayas, they obstruct the jet stream. So in the region of the Himalayan mountains, you have a situation where this jet stream, owing to the obstruction, the physical obstruction of Himalayas, they get divided into a distinct northern branch and a distinct southern branch. Now, if that is the case, now imagine the shift to the north and south. So if there is a shift to the north, the northern branch will get facilitated furthermore. If there is a shift to the south, the southern branch will get facilitated evermore. But when we are talking about the shift to the north, here you have to understand, it is not as if the southern branch will continue to shift and will cross the Himalayas like this, right? If you have, let's say, the Himalayas, one portion has a northern branch, the other the southern branch, the entire jet stream is shifting north. So it will not be that the southern branch will climb over the Himalayas and merge with the northern branch. It is not going to happen. The northern branch is going to be strengthened. The southern branch slowly and steadily will weaken and disappear. Again, during the winter season, when it comes back, again it will face the obstruction of the Himalayas. Again, you will have a distinct northern and the southern branch which is in existence. So that shifting of northern and the southern branch, that is very much associated with the shifting of the jet stream itself. Okay. Yes, Vishal. Southern branch of jet stream is a major reason that we don't receive rainfall in winter. No, we do receive rainfall in winter. In various parts of the country, we do receive rainfall in winter, but you are to the point when you say that southern branch of jet stream is responsible for lack of rainfall, especially during, sometimes you will observe that the month of August and September, rather than bringing rainfall, they are very dry. That is attributed to the southern branch of jet stream when it suddenly appears over India. So October, September, they start becoming drier. Okay. Where is the Himalayan obstruction now? Himalayan obstruction is where the Himalayas are. The Himalayas are not going to shift. It is the various different aspects of the jet stream, the various parts of the jet stream which shift accordingly. But Himalayas are where they are. Okay. So I hope that is understood. Now, before moving into the next portion, we take a break. We take a 10 minutes break and we are going to be back in 10 minutes. Okay. And then we'll continue. Uh, a confirmation about the audio, please. If the audio is available and clear, kindly confirm the same. Thank you. Abhishek, is jet stream affected only northern part monsoon? No, the entire monsoon. The entire monsoon phenomena, if the jet stream is present, even the onset won't happen even in the southern part of India. And that is largely due to the analogy that I have provided of the traffic jam. Yes. So now we come to another factor which influences the Indian monsoon, and that is the heating of Tibetan Plateau. Now, when we talk about Tibetan Plateau, it is a very unique landscape. It is unlike any other landscape that you come across in the sense that it is at a very high elevation. It is the highest plateau across the world, and average height is around 5,000 meters above sea level. That is the average height that you will observe in the case of Tibetan Plateau. Now, this Tibetan Plateau basically is very rocky, granitic rocks, and as a result of that, the solar insolation provides excess and extraordinary amount of heating in the case of Tibetan Plateau. Right? The insolation heats up the region at a very quick pace. So what happens is that this Tibetan Plateau observes high amount of convection because of heating. As the heat is gained and lost very quickly, as a result of that, it experiences a very high rate of convection due to heating. So air which heats up, or as the ground heats up, the air heats up significantly, and that creates a very intense low pressure in this region. Very intense low pressure because the temperature is very, very high. Now, let us take a look at the analogy of it, and let us try to understand what the Tibetan Plateau does. So here, let's suppose we talk about these being the Himalayas, and then this being the Tibetan Plateau. Right. Now, these Tibetan highlands, they are at a height of 5 kilometers above sea level. Okay. Let's suppose this is the region of equator. So here, during the summer months, heating is observed. Heating is observed, and that creates a very intense low pressure on top of Tibetan highland and Tibetan plateau. Now that heating, due to that extreme low pressure which is created, very intense low pressure that is created here, a very intense low pressure, intense low pressure due to heating. So as this low pressure is created, the winds here, they will warm up, they will start rising up. They will start rising up very quickly. They will be able to hit the region of tropopause. After hitting the region of tropopause, the winds will actually diverge. They will move in different directions. Imagine if this is the upper air that we are looking into, the winds will rise up, they will diverge in all different directions from the upper atmosphere. They will be bending to the right, obviously, because of the Coriolis force, right? Now, one of these winds, as they rise up, they will gain a direction somewhat like this in the upper atmosphere. So one of these winds, they start moving southwards. the southward movement that we have seen. They will start moving southwards at a speed of roughly around 90 to 100 km per hour. They will start their move to the southern part, right? All the meanwhile, they will continue. Now, this becomes a part of your almost like the Hadley cell in itself. Now, there, because the ITCZ is also lying somewhere in the region of the Himalayas. So, as it rises up, it eventually will cross the equator, will settle down around the region of the mascarene high pressure, around the high pressure. So, that will strengthen the high pressure. So, the sinking winds or sinking air column strengthens the high pressure, causing or driving more winds on the surface towards India. And more winds, when they are driven across the surface, that means what? More winds will bring more moisture and they will cause greater amount of rainfall. So as the high pressure is strengthened, that means more moisture bearing winds or moist winds are driven to India, bringing more rainfall. Okay, how? So here again I will repeat. Now during the summer season, what happens is that the Tibetan highland, which is a rocky plateau, granitic rocks, basaltic rocks also, they will get very heated up. They will absorb sunlight and they will get very, very significantly heated up. Now, this heating of Tibetan plateau creates that very intense low pressure, due to which the air starts to rise. As the air starts to rise, it is already at 5 kilometers above the sea surface. So it very quickly is able to hit the tropopause. The moment it hits the tropopause, that is when it will start to diverge. Now it will start to diverge in all different directions. From the upper air, one will go like this, other will go like this, one will go like this. But a portion of it that moves eastwards, first of all, and then curves due to the Coriolis force, and then after that they start moving here, right? This is the upper air movement. They will start moving here. They will cross the equator. They will, after crossing the equator, they will bend to the left. They will cross the equator. After that, they will settle down or sink in this portion of the high pressure. Upper air winds sink and intensify the high pressure. Now this high pressure, when it is intensified, means what? That it will start to drive more surface winds. So if, let's suppose, I draw the equator first of all. Now, as this high pressure is strengthened, means what? It means that more surface winds. Let me write here, blue color indicates surface winds, if this is visible, or let me use white color for that. So here surface winds, and yellow color for upper air wind. Okay, so these surface winds will be driven from the region of high pressure. They will come here, cross the equator, just like the trade winds, and they will hit the Indian coastline. So, more the winds that come from the region of Tibet, greater will be the winds moving on the surface towards India. So, that is a kind of a direct correlation. So, here, more winds coming from Tibet means what? Means more moist winds are driven towards India. So that is why this is very important in order to boost the monsoon rain, in order to increase the amount of rainfall received by India during the monsoon months. Now, this upper air movement that you see, this also takes place at a speed of around, the speed of the wind is roughly around 90 to 100 kilometer per hour. 90 to 100 kilometer per hour. That is the general speed that you will observe. Right? So these are what are also referred to as tropical easterly jet, which is a kind of a temporary jet. Why is it referred to as a tropical easterly jet? Because observe the direction. It appears to be coming from an east to the west direction in the upper air. That is why a tropical easterly jet. So overall, if you take a look at it, then during the summer months, the rocks in the Tibetan plateau, they become very hot. They form an intense low pressure region over Tibet. Now, resultantly, the air rises up and diverges from a particular height. The divergent air goes all the way to the southern hemisphere and sinks over the region of Mascarene High or the southern high pressure. This upper air movement is sometimes referred to as tropical easterly jet. And this is an important cycle to strengthen the monsoon. So stronger the tropical easterly jet, greater will be the amount of rainfall. Does not mean if the tropical easterly jet is absent, there will be no rainfall. The rainfall will be normal. It only strengthens it. Okay? Intense heating of Tibetan plateau because of a high altitude and also because of the rocky surface. We have seen that depending upon the type of surface, the amount of heat absorbed or the amount of heat lost, that is different, right? So because it is a rocky surface at high altitude, let's suppose if the temperature in Tibetan highlands or the Tibetan plateau, let's suppose it is somewhere around 20 degrees Celsius, right? Or 21 degrees Celsius. Let's suppose the temperature is 20 degrees Celsius. Very significant amount of heating, 20-25 degrees Celsius can reach sometimes. Now, you might think that this 20 degrees Celsius is not very much, but understand it is 20 degrees Celsius at a height of 5 kilometers. At the foothills of Himalayas in the northern plains, even if you have a temperature of 40 degrees Celsius, assume that during the summer months you have a dry lapse rate. Dry lapse rate means by a height of 5 kilometers. If let's say we assume that the lapse rate is 7 degrees Celsius per kilometer. So at a height of 5 kilometers, you will be experiencing anywhere between 0 to 5 degrees Celsius, right? If we assume that lapse rate is 7 degrees Celsius. If we assume that the lapse rate is 10 degrees Celsius, it will be lower. So at this height, if it is 0 to 5 degrees Celsius, Tibet is offering 20 degrees Celsius. So that is very, very hot, intensely hot. Okay, right? Is that understood, Ajit? Now, after that, we come to the portion of the Mascarene High. Will this type of cell also be formed in North Pacific Ocean? The Tibetan highland portion of cell are you talking about? Which portion, which cell are you talking about, Purnish? It means harsher the Nitin, it means harsher the summer, good for monsoon. Not always so. It is determined by whether in the previous year, let's say Tibet has received lot of snowfall, lot of ice cover. So significant portion of the summer will be consumed in melting of that ice and snow. So then the jet which will be generated will be weaker. If let's say the previous winter has not been very harsh and it has had a kind of a moderate snowfall, that will already melt by the time of late April or early May. So in that case, the heating will be very intense by the time that you reach end of June. So it is the previous seasons, let's say the previous seasons um, winter snow that determines the strength of tropical easterly jet in a way. Okay, Nitin? Then, yes, plated to northern ocean. Will this type of cell be formed in North Pacific Ocean? Pacific Ocean has got its own different kind of circulation and own different kind of circulatory cells. It is not something which is circulated from the region of Tibet. Pacific circulation has got a latitudinal circulation cell as well, a kind of a longitudinal, that, for example, Walker circulation, etc., that you have. So Pacific will have many different, you have a decadal circulation in the ocean as well. So Pacific has got its own very different kinds of circulations which are in existence. Now we come to the portion of Mascarene High. Mascarene High is the high pressure which provides winds to India during the monsoon months, and these winds, they eventually bring rainfall. So always get that clear. Stronger the high pressure in Mascarene High, because these are going to drive the winds eventually over to India, right? So anything which strengthens the Mascarene High will strengthen the rain received in India, because more winds will be driving from Mascarene High. So any aspect which strengthens the Mascarene High is beneficial for the Indian monsoon, and any aspect which weakens the Mascarene High will eventually weaken the Indian monsoon. So it is a zone of high pressure which exists around the Mascarene Islands in the southern hemisphere, and hence the region is referred to as the Mascarene High. During the monsoon months, when it is winter in the southern hemisphere, this is the subtropical high pressure zone. And this generates the trade winds which cross the equator to reach the ITCZ, which during the monsoon months is largely over the Indian subcontinent. Stronger the high pressure, more is the rainfall received in India during the monsoon months. So, strength of the high pressure around Mascarene Islands is directly proportional to the strength of Indian monsoon. Strength of Indian monsoon. Okay. So strength of high pressure around Mascarene Islands, that is directly proportional to the strength of Indian monsoon. So stronger the high pressure, stronger is the monsoon, weaker the high pressure, weaker is the monsoon. So all the various influences that we will see in the case of even El Nino, La Nina, and Indian Ocean Dipole, so all of that will eventually end up influencing the Mascarene High. If let's say when we say the impact of El Nino or La Nina, here they will strengthen or weaken the Mascarene High, and that is how they are able to strengthen or weaken the Indian monsoon as well. So here, when we talk about those, here, impact of El Nino and La Nina. So El Nino and La Nina, we have seen that they initiate their own kind of circulation in the ocean itself, especially around the equatorial region. So Heating of oceanic waters in the Pacific, that is ends up creating the ENSO conditions, that is the southern oscillation conditions in the Pacific Ocean, also has an impact in terms of Indian monsoon. Now, during El Nino, whenever you have the conditions of El Nino, that basically reduces the amount of rainfall received by India during the monsoon months. So El Nino, just remember this itself, even this portion is enough for your general studies, that El Nino decreases the overall rainfall received by India during the monsoon months, and La Nina, on the other hand, increases the amount of rainfall received by India during the monsoon months. So that is something we had taken a look at yesterday as well. Let us try to understand that how this happens or why this happens. So overall, when we take a look at, let's say, the El Nino conditions, or start with the La Nina conditions, starting with the La Nina conditions. So when we have the La Nina conditions, here, the Western Pacific, that is where you have the accumulation of that warm water, right? The air wind rises up. Now observe the region around Western Indian Ocean. Now, what do you think will be the impact of pressure, or if impact of the air circulation on the Western Indian Ocean? Will it lower the pressure? Will it increase the pressure? Or will it have no impact on the pressure? Obviously, it will induce a higher pressure, isn't it? So here, it will strengthen the mascarene high, because here you have a sinking air column. That sinking air column will end up strengthening the mascarene high. So because the mascarene high will be strengthened, the monsoon will also be strengthened. So when we say the impact of La Nina, due to heating of the Western Pacific, there's a creation of low pressure over the region. Now, the air rises up in this particular portion. If you talk about it, the air rises up. It diverges. One portion falls over the Indian Ocean, forms clouds, and after that diverges from the region of tropopause in the eastern and western directions. The part which moves to the west, right, towards the Indian Ocean, eventually subsides in the region of mascarene high, thereby strengthening the mascarene high pressure. This strengthens the intensity of the monsoon winds, and that causes more rainfall. So that is why La Nina conditions, they will create more rainfall. Just even if you don't understand the circulation, even if this basic point is understood, more than sufficient. More rainfall in India. Now recently, for the past 3 years, there has been a condition of La Nina which was prevalent in the Pacific. So that is why, if you take a look at it, 2020, 2021, 2022, all these 3 years, we have experienced the La Nina condition. And that is what is referred to as the triple dip La Nina, right? So we have experienced the La Nina conditions continuously. That is why we refer to it as triple dip La Nina, because it is a very rare occurrence to be observing La Nina again and again and again. Yesterday we had seen and talked about the fact that basically El Nino, La Nina, and the neutral conditions, they are prevalent and they keep on repeating every few years, but generally not in a consecutive manner. So that is why 3 La Nina conditions in a row, and that has led to a condition where the El Nino, which will be created that is in 2024, what is predicted to be created, that is going to be a very strong El Nino. Okay. So does monsoon take place in western coast of Africa also? You have a pseudo monsoon, not a complete monsoon phenomena, Purnesh, but there also you have some reversal of wind which is observed. Monsoon, please understand, is reversal of wind. Monsoon is not the occurrence of rainfall. Monsoon is a phenomena which is associated with reversal of wind. In India, that brings rainfall. That is why we always associate monsoon with rainfall. Otherwise, monsoon is the phenomena which is the reversal. Okay. Now, what happens during the El Nino conditions? When we talk about the El Nino conditions, This is where the warmer water or the lower pressure is present in the region of the eastern and the central portion of Pacific. Now this rises up, sinks in the region of western Pacific. Observe here, you have the rising air column. Now what will be the impact on mascarene high due to this El Nino condition? What do you think? Will the mascarene high pressure be strengthened, weakened, or will it be not impacted at all? So because you have a rising air column here, so it will end up weakening the mascarene high pressure. So as a result of that, you will observe that the mascarene high pressure is weakened. So basically, this induces a circulation which eventually weakens the high pressure system in the region of mascarene high. And as that high pressure system in itself is weakened, that weakens the intensity of the monsoon winds, causing a shortage or a shortfall in rainfall. Okay, so that is how El Nino and La Nina conditions, which are prevalent over the Pacific, they have an impact over the Indian monsoon. Now, we talk about the conditions of Indian Ocean dipole. Now, Indian Ocean dipole has got three conditions. That is the positive phase, the normal, and the negative phase. Now, during the positive phase, warmer waters are present where? Or the low pressure is created where? In the region of Western Indian Ocean and Arabian Sea. During the normal and the negative, low pressure is created where? Eastern Indian Ocean. Now, negative and normal, these are detrimental to Indian monsoon. And the positive phase, that is beneficial for Indian monsoon. Okay, now why and how, let us understand that. So here, first of all, starting with the equator. So here, what happens during the positive, the negative, and the neutral phases? This is the region of high pressure. Let's suppose this is the high pressure. Starting with the negative or the neutral phase. Now, when you have this high pressure, winds are moving. This is the region of ITCZ, by the way. So the winds are trying to come towards ITCZ. So these winds are moving. They will be crossing the equator. And they will be hitting the Indian coastline. Right? Now, when we have a negative or a neutral IOD, in that case, the low pressure is created here. In both and negative and neutral IOD, the low pressure is created here. Now, when that low pressure is created, means what? The winds which were earlier moving to the region of ITCZ, some of those winds will now be diverted. Some of those winds, they will be diverted. Right? So, these winds will now start blowing directly towards that low pressure. Isn't it? So you have a diversion of wind, means lesser winds are moving towards India. And when lesser winds are moving towards India, means they are bringing lesser moisture. That is why whenever you have a neutral or a negative IOD, that is a competing low pressure away from the ITCZ, not in the path of movement of winds towards the ITCZ. So it ends up diverting the winds away from ITCZ. And that is where you have lesser winds coming over to India. So that is where it is detrimental to Indian monsoon, means lesser rainfall. Whereas when we take a look at the positive phase of IOD, in the case of positive phase of IOD, what is the condition that we have? In the case of positive phase, we have a low pressure across the region of Arabian Sea, Western Indian Ocean in general. So, okay. So neutral and negative, how many of us have not understood? Okay, fair enough. So during the case of the neutral or negative Indian Ocean dipole, you have a low pressure in the Eastern Indian Ocean, right? Now imagine a situation where there is no low pressure here. Imagine a condition where there is no low pressure in this region. That is the normal condition. Let's say no Indian Ocean dipole is in question here. So what will be the direction of the winds? The winds will be moving significantly from this high pressure. They will be moving towards the Indian subcontinent, bringing rainfall, right? Negative or neutral IOD means what? It means that you have warmer waters in the Eastern Indian Ocean. That means you have a competing low pressure here, or you have a low pressure, warmer waters in Eastern Indian Ocean will create a low pressure in this region. Now, this low pressure will attract winds from some region or the other. Where will it attract winds? The high pressure is the Mascarene High region. So earlier, let's say five, or let's say some quantity of winds were originating from Mascarene High, all of them were going to India. But now, because you have other low pressure, it will attract some of the winds from the Mascarene High. So rather than these winds coming over to India, these winds which were moving over to India, some of them will still move, but some of these winds will now start moving towards that low pressure. See, winds do not know whether they have to go to India, whether they have to go to Bangladesh, whether they have to go to Burma. Winds do not know, they do not discriminate that, okay, in Kerala I have brought some rain, so I have to bring rain to Karnataka as well, otherwise they will start getting angry, or Maharashtra, they will start feeling alienated. No. Winds will only know where is the high pressure, where is the low pressure. So in this situation, what do you observe? You observe that basically earlier, whatever wind was moving towards India, some part of that wind is now diverted. Some part of that wind is now attracted by this low pressure created in the Eastern Indian Ocean. So that is why this means lesser wind supply to India because of diversion from the Mascarene High. And that means lesser winds to India means lesser amount of rainfall. Is that understood? All of those who have not understood, please confirm. See, when you are confirming that you have not understood, please also confirm that you have understood. Otherwise, it is a moot point in exercise. Does the ITCZ um, does the ITCZ have low pressure in greater magnitude than IOP, Indian Ocean Dipole Low Pressure? Yes, ITCZ has a greater low pressure. It is the most intense low pressure in that entire region. That is correct. But if your question, Dinesh, is the fact that why the from this low pressure the wind is not being attracted by this ITCZ, first of all, the winds in the northern hemisphere, they will get deflected to the rightward direction. And here, this is largely around the equatorial region. So here, it will end up causing significant amount of convectional rainfall. If this low pressure is present in the region of Arabian Sea, it will not cause convective rainfall because there it is very close to ITCZ. But here, it causes a locational rainfall in the region of Eastern Indian Ocean. Sometimes, furthermore, in the region of South China Sea, also the winds can be diverted because the ITCZ is not a single column. The ITCZ is all the way extended here. So sometimes it might get influenced here also. Okay. Is that understood, Dinesh? Okay. So now we talk about the positive IOD. What happens when there is a positive IOD? So in situations of positive IOD, you have the creation of a low pressure in this entire area. Now, the creation of low pressure in that entire area means what? It means that it will attract winds from that high pressure. It means it will attract more winds from that high pressure. All the more winds that it can attract, it will attract towards that low pressure. Once the winds reach here, once the winds they reach here, they will create an oversupply in this low pressure. And ITCZ is the absolute low pressure. It is very, very intense. It is an absolute low pressure. So that will start acting like a corridor. Corridor in the sense it will attract more winds from all the areas. It will channelize it towards the ITCZ. So that low pressure which is created here, it will channelize the winds towards the ITCZ, pushing much more winds towards India as compared to the normal conditions, because this entire region in that case, that starts acting like an intense low pressure. So this channelizes or basically attracts winds from all around and channelizes them towards Mascarene or towards the ITCZ, bringing more rains to India. Whereas when we say about normal and negative, they will pull away, they will divert some of that warm or winds from the Mascarene high, and they will, that means that there will be lesser amount of winds moving over to India when you have normal and negative IOD, because the wind will be channelized towards the Eastern Indian Ocean. But in the case of positive IOD, the winds are channelized towards the region of the Western Indian Ocean. They start acting like a conduit, like a corridor, and they will direct all the winds towards the ITCZ, bringing more rains. Okay. Positive phase, again, if you have to talk about it, understand, positive phase means a low pressure. Excuse me. Positive phase means a very distinct low pressure which develops over the region of the Arabian Sea and Western Indian Ocean. Now, this positive phase means that it will start attracting the winds from the region of Mascarene High and all the nearby areas wherever there is supply of wind, it will be attracted towards that low pressure. But once they have reached that low pressure, the winds get a realization that, okay, the absolute low pressure is somewhere else. Here we still have some surplus of winds. ITCZ has got no supply of, because that is absolute low pressure. So all the winds then start rushing towards the ITCZ. So that entire region of Arabian Sea and Western Indian Ocean, that starts acting like a corridor, a conduit, a kind of an attractive quotient, which attracts the winds and channelizes them towards the region of ITCZ. So more winds that are channelized and thrown towards India, they will be crossing the region of the oceanic waters. In the meanwhile, they will be bringing more rainfall. Okay. Now, after this, we talk about the entire mechanism. We talk about the entire mechanism of the southwest monsoon one by one, that what happens and how it pans out. So, first of all, we have to understand that this southwest monsoon, the entire phenomena in itself starts getting initiated from the month of late April and May, when there is significant heating of the landmass. Significant heating of the landmass creates that low pressure, and that is what shifts the ITCZ to the north, and that is where the winds are attracted all the way from southern hemisphere. The winds are attracted, but they will not hit the landmass. Why? As long as you have the southern branch of the jet stream. Eventually, when the jet stream finally disappears, that is when the winds will start moving in mass, and that is when we say there is an onset of monsoon. Later on, the amount of rainfall, the amount of winds, they are basically impacted by the tropical easterly jet, by El Nino, La Nina, by Indian Ocean dipole. But that simply influences the amount of rainfall received. Okay? So we will take a look at the mechanism one by one. Is there, Ajit, is there any chance occurrence of both La Nina and positive IOD in Indian monsoon? Absolutely, yes. This has happened. So when you have La Nina and positive IOD, both of them, they exaggerate the amount of winds that come towards Indian coastline, and that can cause excess rainfall, flooding in many parts of the country. Is it possible that El Nino and negative IOD can happen in the same year and results in no monsoon wind? No monsoon wind is not a possibility. Some monsoon winds will be there because the ITCZ is there. The trade winds, they want to reach the ITCZ. So you have a very drought-like condition, significantly drought-like conditions. For example, we have experienced that around 2009. That is where you had an exaggerated drought because of negative IOD and El Nino. Conversely, El Nino and positive IOD can occur, counteracting each other's impact. Okay, so all these permutation combinations, they can occur. So first of all, we start with the aspect of the ITCZ. This ITCZ shift is initiated basically by the heating of the landmass. The landmass gets heated up, and that is where the ITCZ starts shifting to the north. So the ITCZ, once it shifts here in this region, that means the trade winds from the south. Now, please understand, it is again, if I ask you, this ITCZ has not shifted there suddenly one day you open up your eyes and ITCZ is over Rajasthan. No. Initially, the movement of ITCZ, it will be like a phase-wise manner. Late March or early April, right? Early May. And then you have June. So by the time of end May and June, the ITCZ reaches here. So let's say we consider the portion of March, first of all. So if late March, so here, when the ITCZ is up till here, that means during this time, the moist winds or the moisture bearing winds, they will be reaching up till here. That will be their destination. Let's suppose then we talk about April. So by that point of time, the winds will reach here. Right. So that is why These winds, this phase is also referred to as the advancing monsoon. Advancing monsoon. That is, the ITCZ is slowly and steadily advancing over the Indian subcontinent, bringing the moist winds along with it. And what is the direction of the wind? Southwest to northeast. So wind direction is, when we talk about the wind direction is from southwest to northeast. That is why advancing monsoons are also referred to as what? They are referred to as the southwest monsoon. They are referred to as the southwest monsoon in general. Then, after that, here, when is it that the onset of monsoon will happen? So that is again another important phase in the development of the monsoon. When is it that the onset will be observed? So here, if this is the equator, let's suppose the winds have reached this place. Let's suppose the winds have reached here, all these winds. Here also they have moved and they have reached here as well. But there is a large traffic jam created because of the presence of subtropical, southern branch of the subtropical westerly jet stream, which is prevalent, which is present over this region. Right? This is the southern branch of subtropical westerly jet stream. Subtropical jet. So, as soon as this southern branch will disappear, that traffic jam will be cleared. And that means all the winds will suddenly start to move. So the moment it disappears, as it vanishes, the winds rush in. Okay? And that is when initially it is across here, the Malabar coastline across Kerala, that will start receiving very heavy amount of rainfall. And here after that, if you take a look at it, basically, let me tell you about the distribution of rainfall, how the rainfall is distributed across the country during the advancing phase of monsoon. So here, if I have to draw the equator again, let's suppose this is the equator. So here, what happens is, let's imagine that the southern branch has vanished. So first of all, here you will have the winds hitting this region, Kerala coastline. That is where we declare it as the onset of monsoon, that the monsoon has arrived. If it has rained consecutively or continuously for the 5 days with the amount of cloud cover, all of that is measured and then the onset is declared. Now, meanwhile, you have winds which in the region of Bay of Bengal, which also start entering through the region of Bangladesh, right? Now, meanwhile, it spreads across the Kanara coastline, the Karnataka coastline. Some part enters inwards through the gaps in Western Ghats, causes rainfall in the old Mysore belt, that is the Mysore Bangalore belt that you have. They will start receiving rainfall. Now, here, in around 10 to 15 days, this rainfall reaches up till the region of Maharashtra coastline. Now, this is divided into two branches. This is what is Arabian Sea branch of monsoon. Arabian Sea branch. And this is what is referred to as Bay of Bengal branch of monsoon. Right? Now, this Arabian Sea branch in itself trifurcates into three parts. One of them, one part will hit the Western Ghats continuously and keep on bringing rainfall across the Western Ghats. Some of them will cause residual rainfall in the interior portion as well through gaps in the Western Ghat. They can cause rainfall in the region of Bangalore, in the region of Pune, in the region of Nashik, because you have various gaps in the Western Ghat, Thal Ghat, Bhor Ghat gaps that are present that allows the passage of these winds, and they will cause some amount of rainfall in the interior regions as well. Some amount of rainfall in the interior regions as well. Then one part of this Arabian Sea branch that moves between the Vindhyas and the Satpuras, and it causes rainfall in the Amarkantak region. The Amarkantak hills and the plateau region that you have in central India, which is a source of rivers such as Son, Mahanadi, Son, as well as Narmada, as well as Rehan. So that is basically the region which will receive rainfall from the Arabian Sea branch of monsoon. The third part of it, it starts moving north. It moves parallel to the Aravallis and it reaches the northern plains. Meanwhile, the Bay of Bengal branch that hits the Himalayan mountains, and here one part gets diverted to the northeastern region. After getting diverted to the northeastern region, here the winds are stuck and they cause immense amount of rainfall, high amount of rainfall in that region. Some of these winds, they will, owing to the obstruction by the Himalayas, these winds, they start traveling westwards. And they start traveling westwards and they will cause rainfall in the foothills, the northern plains, and eventually they will meet up with the Arabian Sea branch of monsoon. It will be a happy reunion and they will cause rainfall. In a way, you can think about it that as you move farther away from the coastline, amount of rainfall reduces. Closer you are to the coastline, greater is the amount of rainfall received. That is why in India, you can always say that the amount of rainfall reduces as you move from south to north or as you move from east to west. As you can see, the region of Punjab, Haryana, Western UP, there, Himachal, there, the monsoon winds, they reach at the end, right? So there, the monsoon winds will reach at the end. So that is why minimum amount of rainfall, very little amount of rainfall is caused at that point of time, right? So again, the Arabian Sea branch gets divided into three parts. One hits the Western Ghats, the other passes between the Vindhyas and Satpuras, causes rainfall in Chhattisgarh, central India, around Amarkantak, and the third branch moves further northwards because the Aravali ranges are parallel to this. These are, let's suppose, these are your Aravalis. So the Aravalis are parallel to it, so they offer no obstruction. That is why western part of Rajasthan is a desert. As the winds, they further march north, they will hit the Himalayan mountains again and cause rainfall in the northern plains. Okay, so that is the aspect of the rainfall distribution in India. Are we comfortable up till here? Now, during the phase of the advancing monsoon, another aspect that you will observe is that these winds, they are moving in this manner. If you observe the Coromandel coastline, that is the coastline across Tamil Nadu, the Coromandel coastline, that is the one which does not receive rainfall. Why does the Coromandel coastline does not receive rainfall? That is because the Coromandel coastline is parallel in a way to the wind movement. Very good. And that is why Coromandel coastline does not end up receiving rainfall during the advancing monsoon. All this you will get in the written portion in the additional reading material. So don't start frantically taking notes if at all you are. So during advancing monsoon, Coromandel coastline does not receive rains. Okay, right? So that is the aspect of the monsoonal wind distribution, that you have the Arabian Sea branch, you have the Bay of Bengal branch that enters. Why is it that you have a Bay of Bengal branch? Because the shape of the Indian coastline, the Indian peninsula, is such that some of the winds, they will be diverted towards the region of Bay of Bengal. Then they hit the Tanasarim, Pegu Yoma, Arakan Yoma mountain ranges, which are situated in Myanmar. That provides them directionality, that makes the winds enter from the region of Bangladesh. And that is where these winds, they hit the Himalayan mountains around the region around Sikkim, North Bengal, and they cause immense amount of rainfall. Some of those winds, they divert towards the region of the northeastern area, and that causes humongous amount of rainfall in northeastern states. And the rest of the winds, they are diverted to the west, and they cause rainfall across the northern plains. Again, I will ask, is that understood? If you are active enough, if you are awake enough. Okay. If that is understood, can we elevate the concept, or are we comfortable here as well? If we are comfortable up till here, fair enough. Otherwise, we can elevate the level of concept ever so slightly. And but that is also not very much needed. But if we are comfortable up till this point, I would want to tell you something more about the Indian monsoon. Generally, something which is not found in the books. Okay, so yes, we are comfortable. Fair enough. Now think about it for a bit. Whatever we have said and we have talked till now, I hope we are very comfortable up till this point. Whatever we have talked about it, all this is about the monsoonal distribution and rainfall. Now, if you apply your logic here, think about it, that why is it that this Bay of Bengal branch of monsoon, why will it start moving leftwards? It is okay to understand that, fair enough, it is diverted by the Himalayas. The Himalayas are offering an obstruction. But why will they reach all the way almost up till Punjab? What can be the reason for that? Some divergence can lead them, let's say, to Bihar, to Jharkhand, to eastern Uttar Pradesh. But why will they reach up till the region of Punjab? And here also, another aspect I want you to think about it. In all these, we have not talked about the region of Madhya Pradesh. We have not talked about the region of, let's say, Maharashtra. So those areas also receive rainfall. How do they receive rainfall? Here we have not talked about Jharkhand, we have not talked about southern Uttar Pradesh. How is it that these areas receive rainfall? After all, the ITCZ is extending all the way apparently across the northern plains. So how do these areas get rainfall? That is basically here due to low pressure cells, what are also referred to as monsoon troughs. Monsoon troughs, when we talk about it, monsoonal troughs, these are extreme low pressure cells formed over land due to extreme heating. These are different from ITCZ. Sometimes it can happen that ITCZ converges with the monsoonal trough. That creates very intense low pressure. So what does this monsoonal trough look like or appear to look like? So if I can use one of those maps, I hope I can use this map. I hope that you guys are comfortable with the portion of the ITCZ shifting. So I don't think you will have an issue if I erase this. Anyways, you'll be able to look at it from the recordings as well. So here, how are these monsoonal troughs created? So when you have excessive amount of heating, there are these low pressure centers which build up. These low pressure centers build up. These low pressure centers, they are referred to as the monsoonal trough. These are very different from ITCZ. ITCZ also operates in the forms of low pressure cells, but it is sometimes that this ITCZ will converge with the monsoonal trough. In that case, very intense low pressure. Otherwise, this monsoonal trough in general, you will come across a scenario that this is your general axis of monsoonal trough. Overall, during the entire season of the monsoon, right from the last week of May all the way till September, you have around 6 to 7 monsoonal troughs which are created. It is not as if it is created every day and it will rain every day. No, only around 6 to 7 of these troughs are created. These troughs, they shift northwards or southwards depending upon the heating of the landmass. If they shift slightly to the north, that is, let's suppose these monsoonal troughs, they indicate a pattern like this. You will observe that during those years, the Bay of Bengal branch of monsoon, the Arabian Sea branch of monsoon, they will cause high amount of rainfall in the Himalayan foothills and the northern portion. Whereas the region of Telangana, the region of Maharashtra, Vidarbha area of Maharashtra in particular, northern part of Karnataka, western part of Andhra Pradesh, they will be very dry. Generally, during the month of August and early part of September, these troughs, they start their motion because by that point of time, northern part has received rainfall, the central and the southern part is still dry. So that is where the central and the southern part, they develop that low pressure. And around that low pressure, all the rainfall starts to happen. That is why, if you have observed for the past 3 to 4 years, it is during the month of August and September, during those months when it rains, it is not the Himalayan rivers which flood. It is the river Godavari, the peninsular rivers, Krishna, they start to flood. The Himalayan rivers, when they have to flood, they will end up flooding in the later part of June or early part of July itself, because that is where the monsoonal troughs are. So always understand that this entire aspect of Bay of Bengal branch, Arabian Sea branch, it is not as if they have a predetermined route that I have to go there. I have to reach the Himalayas, I have to reach that portion. No. It is these troughs which suddenly they determine the directionality. It can happen that, let's say, the troughs, they are formed here. Let's suppose you have a trough which is present here. Now it can happen that the winds are trying to reach there. They are unable to reach, but they are trying to reach there. Let's say through the gap, they have reached there, they have caused very high amount of rainfall. Now every place in the pathway of that trough, every place will receive rainfall because the winds are going towards that trough, causing orographic rainfall in between. After 5 to 7 days of continuous rainfall, 10 days of continuous rainfall, this trough shifts. Why? Because after 5 to 7 days, 10 days of continuous rainfall, the temperature starts to cool down. It becomes slightly cooler. Now, the other place which has not received rainfall till that point of time, that becomes hotter. So let's say there is another competing trough which has developed here. Now, what will happen to the wind direction? Will the wind direction remain the same? No. The wind direction is going to change. So the wind direction here will start following here. So the winds that you observed in this region, they are going to disappear. So that means for the next 10 to 12 days, this entire region is going to be very dry. You would have experienced, and if not, at least experience it this year, whichever part of the country you are in. When the onset of monsoon happens, you will receive very high amount and heavy amount of rainfall, let's say for 4 to 5 days. After that, you will come across a scenario where suddenly, for the next 5-10 days, there is no rainfall, 15 days, no rainfall. You are left wondering that whether really in reality monsoon has come or not. That is directed by these monsoonal troughs. And this gap in the monsoonal rainfall, after the monsoon has arrived, still you have 10-15 days of absolutely dry condition, no rainfall at all. Why? Because the winds have changed direction. They are going to someplace else. It can happen, let's suppose you are in Indore. It can happen that there's a trough in the region of Nagpur, you are not receiving rainfall at all. When the trough transfers over to Indore or Bhopal or that region, Nagpur will start experiencing drier conditions. Slowly and steadily, that will also heat up. And this trough is nothing but a low pressure. Trough means a low pressure. Trough, depression, disturbance, all of that is associated with low pressure. So this low pressure is created purely by heating. So sometimes after the monsoon has arrived, onset has been declared, it takes almost a month to cover the entirety of country. After that, during that time, when you have a gap of around 1 week, 10 days without rainfall, that is what is break of monsoon. That is what is referred to as breaks in monsoon. Sometimes it can also happen. Let's suppose the absolute thermal low pressure created by ITCZ, it coincides with the monsoonal trough. It can happen. Now, if that happens, if there is a thermal low pressure of ITCZ, which is a larger phenomena, and the monsoon trough also coincides with that region, you can only imagine the intensity of low pressure. Suddenly, you have multiple levels of convection. Air is not only going to rise from the ground surface, even from the middle level of troposphere, air is going to rise up. That is when you come across cloud cover, which can be 10 kilometers in thickness. 10 kilometers, even sometimes 12 kilometers thick cloud cover. Very intense thunderstorm, very heavy rainfall, continuously for 2 to 3 days, 3 to 4 days. That is what is referred to as a burst of monsoon. Okay? So that is how the monsoon tends to operate around these low pressures. In the books, you will find the definition of burst and break in monsoon or the monsoon rainfall, but that is nowhere close to being accurate about the reality. The burst happens when you have sudden onset of rainfall. And that happens when the ITCZ tends to coincide with the monsoonal trough. That is when suddenly there is increased convection. Convection not only from the ground, from air above as well. So imagine if there is an air movement, the air will rise from the ground surface, there's an air rising from above as well. So just to give you a visual representation, if suppose this is the region where there's a convergence of ITCZ and the monsoonal trough, this will attract winds. Now these winds have a vertical thickness as well. Now, while the upper level will start rising straight away, this will also start rising. So that is when you have multiple layers of clouds, very heavy thunderstorms. And it cools down the weather significantly because of continuous outpour and continuous downpour and rainfall. That is what is a burst and break in monsoon. Okay, so that is the level of aspect of Indian monsoon that you will not find. I can give it in guarantee you will not find in the various different textbooks. So use it to understand the phenomena. Why I have told you these things, not because of a particular affinity that I have developed while discussing the monsoon, but it is primarily because this is the time of the year and you will never get that opportunity. Generally, when we read these topics, monsoon has already come or is still far away. This is the time of the year when the monsoons are developing over India. Every day will bring a news story. So for the next 1 month, just observe the news headlines. You will come across these terms that will reinforce the concept. And once you understand this aspect, you will never be required to study the books for the monsoon again. This will be more than sufficient, more than enriching for what you need for your examination and even beyond that. Okay? So I hope that is understood. Is there any doubt which prevails? Good. Anyways, generally around lunchtime, people don't have doubts. It is immediately after lunchtime that people will have doubts. So I hope it is understood. Fair enough. So now we will take a break and we take a break for an hour, right? So 2:05, we meet again after lunch. So take a lunch break, digest the portion that we have just talked about, think about it, try to internalize it. Arabian Sea branch winds are coming from, all the winds are coming from southern hemisphere only, Aarti. All the winds are coming from the region of masculine high pressure. They are coming towards the ITCZ. All of them are getting attracted from here and here they are getting diverged. Observe the wind direction that I had indicated to you. If you remember this satellite image that I had shown to you, that satellite image is foretelling because observe the wind direction, where the wind is coming from. Wind is coming from here, here. It is crossing the equator. It is reaching here. So both Bay of Bengal and Arabian Sea are coming from here. So cloud burst and monsoon burst are different, very different. Burst of monsoon is very different from a cloud burst. Okay? Right? So we take a break, we take a lunch break, and we are going to be back at 2:10 p.m. Yes. Bay of Bengal branch towards northern plains because of the monsoon trough, Pranay, yes, and partially due to the obstruction offered by the Himalayan mountain range. Okay? Let's take a break now.